explain why a poor sampling plan can result in misleading conclusions. Well, to do that, we need to talk about a couple of definitions. So first, bias. The results of the sample do not represent the population. If that is the case, then we have bias in our results. So that could be from any number of reasons, but we want to make sure when we are doing any kind of survey or study that the sample that we use is a good representation of the population to avoid bias. And we have sampling bias, when the method used to obtain a sample tends to favor one part of the population over another. So let's say you're in a city and you want to talk, do a survey on nightlife downtown, and you only survey 20 people from the east side of town. Well, that's sampling bias because you need to make sure you're talking to people all over the city. So that's kind of the idea when you just favor one part of the population over any other. Non-sampling error. This is caused by a factor that is not related to the sampling process. So it could be anything, but this is something that you really probably don't necessarily think about at the beginning, or you don't take into account, but it causes a problem in your sampling that you may or may not be able to really navigate around. It might be something that's just going to happen no matter what. Might be something you can avoid. It just really depends on really what it is and what you're sampling up, what your process, what your actual survey or sample is. And then we have sampling error. This is the natural variation that results from selecting a sample to represent a larger sample. Because here's the thing, unless the population of something is pretty small, you're going to have to use a sample, right? Like, let's say you want to do a survey of adults in the United States. There is no possible way to talk to every single adult. There's just too many, and some are just not reachable, right? So you're going to have to take a sample of the adults in the US. And because you're doing that, you're going to have some natural variation. There's not a way to really say this is exactly how the population would respond because you don't know that. So this is just from taking a sample and making estimates about a population. That's what comes with sampling error. Now, a few things to remember when we're talking about sampling and bias and all of this is the best way to avoid bias is to use random sampling methods. So we want to avoid convenience sampling, like the example I gave about the city and only talking to people on the east side. That's convenience sampling. So we want to avoid that. So we want to use simple random sampling, stratified, cluster sampling, systematic. These are all different methods of random sampling to ensure that we have a variety in part of our sample to have a better representation that will help us have, better and more accurate. We're not going to be perfect, but better data. Also, we want to use a large sample size. Now, large is hard to quantify, right? Because maybe large in some aspects would be 50 and maybe large is 2,000. The more you can include in your sample, the better, because that's going to reduce that natural variation we talked about. So the real key is just to make sure you have an appropriate largish sample size to allow us the best thing. If you do that, have a large sample size and have a good random sample of the population, that will help you avoid bias and lead to better conclusions.